Hello and welcome back to Algebra. We are talking about probability today. We're in Chapter 9, Section 1. Probability of an event compares the favorable outcomes to the possible outcomes. We looked at this in today's lesson, so here's just a couple of additions to it. So if you have probability of rolling a 3 on a number cube, that's 1 favorable to 6 total. Or heads is 1 out of 2 total. And you can write that as a percentage by dividing numerator by denominator. This is the scale of probability from 0. For example, rolling a 7 on a number cube, there are 0 7s out of 6, so 0. Or rolling a number 1 through 6 on a number cube. Well, that's certain. You will roll a number 1 through 6. Sample space shows all the possible outcomes. You can make a tree, or you can make a table like this to show the sample space. You can make a table if there are only 2 events. So, for example, coin and die. You can make a table like this. This shows you the sample space. Okay? And then you can use that sample space to say how many total outcomes are there and how many favorable outcomes are there. Okay, in this case, 3 out of 12 would be even and heads. You can either count those from your sample space, or you could calculate that, say evens is 3 out of 6 and heads is 1 out of 2, and multiply them. Theoretical, we talked about theoretical and experimental probability. Experiment is what actually happens. Theoretical is what should happen, what you'd expect to happen, and we flipped coins for that. We found that experimental probability is not always the same as theoretical, but the more often you do an experiment, the closer it gets to being the theoretical probability. Okay, we found experimental probability using this example, saying we have to add up all the frequencies, how often it was rolled. We found 29. And of those, 6 were the number 6, so the experimental probability was 6 out of 29, whereas we expect it to be 1 out of 6. That would be 17, so the experimental probability was greater than the theoretical. All right, now if you want to find the probability of a complement, all right, so we can find the probability of the sum being 6. Right? So the sum being 6 would be 3 and 3, 2 and 4, 1 and 5. So all of these right here, 3 and 3, 4 and 2, 1 and 5, all of those add to 6. Right? We can find the probability of those. Probability of the sum not being 6. I can either count all the others, or I can say the probability of not 6 is the same as 1 minus the probability of 6, of a sum of 6. Sum, not sum of 6. Okay, the probability of the sum of 6, because if I just subtract these from the whole thing, then I have that same probability there. So I can just say 1 minus, and this is 5 out of the 36 total, so 5 out of 36, and that would leave me with 31 out of 36, or approximately 0.86 or 861. Okay, so sometimes it's a little bit easier just to find the complement, because finding the 6 here, same thing here, less than or equal to 8, well, to 9. So the other ones would be greater than 9. So what's greater than 9? 10. Okay, so we have 10. All of these add up to 10, and everything above that. So that's, in this case, we have 1, 2, 3, 4, 5, 6. So there are 6 out of the 36. So probability of it being, the sum being less than or equal to 9 is the same as 1 minus the probability of a sum of greater than 9. Okay, so that's 1 minus 6 out of 36, and that is 30 out of 36. We can simplify that down to 5/6, and that is about 0.83. All right, so that's finding a complement. Sometimes it's easier to say, okay, how many are the opposite, and then we subtract that from 1. Okay, now using area, this can be a little bit tricky. Okay, if I want to find the probability of hitting the 10, well, then I have to find this area compared to the entire area. So I would write my fraction, say the small area with the 10 there compared to the entire area of the dartboard. Right, that would be my probability. The center, the 10 right here, and this is the entire dartboard, part to whole. Okay? Now, if we want to compare these, which one are you more likely to get, then we have to find each one of those individually. So I'd find the area of the smallest circle, and the area of the smallest circle is pi r squared, and that radius here is 3. 3 squared pi r squared over 18 squared. Type that in, and we can simplify this either to pi over 36 or approximately 0.0873. Okay, so that's the probability of hitting 10 points. 0 points, I'd have to take the entire board and subtract this large circle right here, where this is 3, 6, 9. So that has a radius of 9. So halfway is 9, which makes this side, the full side, 18. Oops. Okay, there we go. So the outside largest circle is the area outside the largest circle. So just this right here, this segment outside there, is 18 squared, which is the full square, minus the circle, which is pi times 9 squared. Okay, that's the large circle. And then out of the entire board, which is, again, 18 squared. All right. And once we calculate that, that comes to about 0.215. So you're more likely to hit this area out here than you are to hit that area in there, because the probability is greater there. All right. One last example we want to look at here. In the United States, a survey of 2,184 adults ages 18 and over found that 1,328 of them had at least one pet. The types of pets these adults have are shown in the figure. What's the probability that a pet-owning adult chosen at random has a dog? All right, so we want to find dog. We want to take that part, 916, to the whole. Total pet owners, okay, of pet owning. Okay, very important that you discern this, what they're asking. They're asking pet owning, and how many of those have a dog. So pet owning means these right here, so that's 1328. That's the probability of pet owning people having a dog. And that can be simplified down to 229 out of 332, or approximately 0.690, which is 69%. The probability of a pet owner in this having a dog is approximately 69%. There you go. If you haven't completed this, go ahead and work in your workbook. Otherwise, good times.